Hi, I'm Alex. I'm one of the three core developers of BayBE, next to my two colleagues, Adrian Sosic and Martin Pitzner. And BayBE is an open source software that we are developing at Merck KGaA, Darmstadt, Germany. So, as I said, it's an open source software for Bayesian optimization. We've also already seen one of its usages. So, thanks again, Janet, for mentioning us here. And it's a package that is still under continuous development with three core developers, Adrian, Martin, and me, but also 10 and more time-to-time developers. And although BayBE was built by industry, it was built at Merck KGaA for our use cases, for the stuff that we are interested in that is relevant to us. It's available to everyone, and we have quite a lot of features, not only for the problems that we are interested in, but where we also believe the community might benefit from, like active learning. We have specific chemical encodings. We support hybrid optimization, transfer learning, and single and multiple target optimization via Pareto and desirability optimization. So please check out BayBE. Please have a look at it. And yeah, if you're interested in our package, just contact me or any of the other core developers. But my talk is not about BayBE. My talk is about how do we actually use BayBE, because I took the title Stories from the Front Lines very literally and want to show you three stories from our usages of BayBE. So the first one is related to the comparison of Bayesian optimization versus design of experiments that Morten has already talked about in his introduction early today. And I also want to stress this a little bit. So what we did and what we always do to convince people that Bayesian optimization is something that they should do is we share the following story with them, which is that we once tried out a simple virtual process to simply compare Bayesian optimization and design of experiments, where this virtual process contains these 5 parameters and one target function. And what you can see on the slide here is the comparison of just the optimization of this virtual process with BayBE shown in blue, compared with just doing random choices, and the results that you get from design of experiments. And what we see is, first of all, Bayesian optimization offers you this iterative procedure that we've talked about quite a lot about already. So you could say that, hey, after 10 iterations, my solution is good enough. So I stop here and I'm happy with what I do. And compared to DOE, you do not need to do the full set of 29 experiments to actually get any result at all. But even then, what you see here when you make this comparison is not only can you just say, hey, let's stop at an earlier point in time, if you actually do the same amount of experiments compared to the design of experiments that you do, you actually get a significant better result. And this is now only one example where we have this sample virtual process with 5 parameters, but this gets really significant if we start adding more parameters. So what we also did is we did the similar experiment, but just added 5 dummy parameters that have nothing to do with the actual target. And you see here, BayBE still is able to basically fully optimize nearly this process. Random is doing, well, randomly, so it's doing something. But you might wonder yourself, but wait, wasn't there a cross for the DOE in the previous plot? Where is it now? And it's still there, but it's like over here. So as you can see, DOE in comparison to Bayesian optimization and iterative experimental planning, you can do it, but you do first way more experiments that you need to do. You get a worse result. So basically, if your process and if your application allows you to use Bayesian optimization and iterative experimentation planning, as we've also talked about previously about this, Bayesian optimization is just the tool that you should actually use and not design of experiments. So that was the first story that I wanted to share, is that comparison between Bayesian optimization and design of experiments, because that's something that we always need to educate people and our users about, because people are just not aware of these differences and of the advantages that Bayesian optimization yields you, and that you just get better results. First of all, that's always good. But second, you even get them faster. So not only better, but faster. However, that's not the only thing that Bayesian optimization can give you. The other thing is that Bayesian optimization can augment human knowledge and avoid existing biases. And for that, I also want to share another story with you, and that's the story about container design. So if you first look at the plot at the right here, there are 15 different designs for something that we did. And here at the right end, you see that there are designs proposed by BayBE, and on the left, these designs were proposed by the experts. And we see that first of all, the designs that were proposed by BayBE, they are very good compared to the designs that were already there. They're not like extraordinarily better, not like plus 10% or something like that, but they're definitely on the top end of what has been done. But this is not the point that I want to make here. The point that I want to make here is that one of the feedbacks that we got for this use case that we did internally is that for our container design problem, BayBE suggested a better variant. So first of all, that's always nice. As I said, Bayesian optimization typically gives you also very good results. But what was interesting was not only the magnitude at which it was better, but the somewhat unexpected design it proposed. Our engineers were interested in this and studied the suggestions to learn new design principles. So that is a quote of one of the stakeholders that actually worked on this use case. And literally what happened is that they did their their designing with BayBE of that container. They looked at it and they were, that's interesting. We would have never thought of that, but that might actually work. So let's investigate this further. So not only is Bayesian optimization improving your processes, it can also help you to just discover whole new things and whole new parts of the search space, basically, and of your parameter space that you as an expert might not ever have considered, maybe just due to your bias or to your previous knowledge. And the third story that I want to share is the big vision, so to say. So where to go with Bayesian optimization, iterative planning in general, and what's our opinion there. So first of all, this is obviously just the topic of autonomous labs. So the question always that we need to answer first to our stakeholders is, well, now give me numbers. How much time, effort, money, arbitrary KPI can actually be saved if you would start having closed loop systems or an autonomous lab? And luckily, there's research for that, there's science for that. So we don't have to estimate an answer or guess something, but we can say that up to 95% is the number that we can confidently give that closed loop systems can actually save. So you can achieve a speed up of 15 to 20x by closed loop systems and autonomous labs. But of course, this is now just one publication. This is some research that people have done at some point, and we wanted to see, does this actually work? Is this actually true? How can we actually convince people that this is not just something people just did somewhere out in the world, but that this is really true, that autonomous labs can actually help you? And for this experiment, or for this year, to convince our stakeholders of that, we did one experiment where we just set up such an autonomous lab in a very, very simplified fashion. So what you see here on the right is a flow chem reactor where you have stuff that's going in, stuff that's being measured, and stuff that's happening in the inside. So unfortunately, I'm not a chemist. My background is actually mathematics, so I can't give you more details on what actually is happening here. But for those of you who are able to read reactions, this is what's actually happening within the tube. So what we are doing in this experiment is that we have a reaction that you see here on the left, and there are two products. There's the first product and there's the second product. And what we want to do is we want to maximize the yield of the first product. So that's what we want to have, while minimizing the yield of the second product. And this experiment had 4 settings. So the EDAC and base concentrations and the temperature. And the optimal choices in comparison to the DOE stuff that I've shown you earlier, we don't know the process here in detail. We cannot like write down mathematically, oh, that's now the best thing that we can achieve, that these are the settings that we need to do. This was really a setting where nothing was known a priori. And when we set up the process and just let it optimize itself literally overnight, so it was left at the laboratory and just did its thing, What you see here is in the first two plots, basically the control and what was changed. So the temperature range in which the experiment was then carried out and the fields of the three different chemicals. And on the bottom, you see the actual yields and how they evolve over time. And you see, quite interestingly, in the beginning, something is happening, it's a bit exploring, then a not that nice configuration has been found because it just brought everything down to zero. And then you see that a good point was found and that the exploration really starts at the exploitation. And if you analyze this data in a little bit more detail, and then you can see that, well, it only took 9 iterations until the yields are above 70% of what's possible and less than 2% for the first, respectively, second product. And if you wait a little bit more, so if you go to 14 iterations, the yields are actually larger than 80 and less than 0.2. And this is the story that we always share with people if we want to show them, hey, autonomous labs, closed loop systems, Bayesian optimization, basically all of what you actually want is already there. It's already working. Look at the data, look at the plots. This is what you want. So start working with it. And yeah, so let me quickly go back to the first slide because I don't have a dedicated last slide. So these are the stories that I wanted to share. If you have any questions, if there's anything you would like to know about BayBE, feel free to reach out to us. Visit our GitHub, leave a star, leave a comment, leave an issue if there's anything that's not working for you. Contact me just on LinkedIn if you're interested in that. And yeah, thanks for listening to the stories that I wanted to share.